Alright guys, this is another review of systems and matrices. So we're starting over with part 1. I'm calling it part 1B because we had a review already in day 12. That was part 1, part 2, and part 3. So this will be another part 1, part 2, and part 3. It's a second review. So let's get started. Draw a vertex edge graph to represent this portion of the United States. Let each state be a vertex and then draw an edge between two vertices if the states share a border. So you just can randomly put vertices to represent these 6 states. So for example, alright, you can have I and O and P and K and W and M, okay, to represent each one of these states. Okay, let's see. So Indiana shares a border with Ohio and Kentucky. Okay, so Indiana to Ohio and Kentucky. All right, Ohio shares a border with Kentucky and West Virginia in addition to Indiana. So Ohio shares a border with Kentucky and West Virginia and Pennsylvania. Alright, Pennsylvania shares a border, of course, with Ohio, but also West Virginia and Maryland. Okay, so West Virginia and Maryland. Alright, Maryland, in addition to sharing a border with Pennsylvania, Maryland shares a border with West Virginia. So Maryland shares a border with West Virginia. West Virginia shares a border with Maryland, Pennsylvania, Ohio, and Kentucky. So there's Maryland, Pennsylvania, Ohio, and Kentucky. Okay, so there's your vertex edge graph right there. Now, for number 2, we're supposed to make matrix K that represents this vertex edge graph. Okay, so what you do is you make a matrix. These are 6 vertices, so we're going to have to do 6 by 6. So the order of the letters doesn't matter, but across the top you're going to put all of the vertices. So I, O, P, I'll just keep going around. M, W, K. And then you have to do the same thing down the side. I, O, P, M, W, K. Alright. Now I'll put numbers in here reflecting whether or not a state shares a border with another state. Now, a state can't share a border with itself, so there will be zeros all along this diagonal to represent the fact that West Virginia cannot share a border with West Virginia, and so on. Now, every number I put down is going to be duplicated. For example, I see that Indiana shares a border with Ohio. Okay, which means Ohio shares a border with Indiana. Okay, also Indiana shares a border, let's see, Indiana shares a border with Ohio and Kentucky. And that's it, just Ohio and Kentucky. So there's Ohio and there's Kentucky. Okay, so here's Ohio and Kentucky. The rest of these will be zeros, because it doesn't share a border with any of these other states. Okay, now on to Ohio. Ohio shares a border with Indiana, which we've already talked about, but it also shares a border with Kentucky, West Virginia, and Pennsylvania. Everything except for Maryland. Alright, Kentucky, West Virginia, and Pennsylvania. So when we do Ohio, okay, there's Kentucky, West Virginia, and Pennsylvania. Okay, so looking at Ohio this way, there's Kentucky, West Virginia, and Pennsylvania. Everything except for Maryland. Maryland gets a 0. Okay, Pennsylvania shares a border with 3 things: Ohio, West Virginia, and Maryland. So there's Ohio, West Virginia, and Maryland, but not Kentucky. Okay, looking at it the other way, okay, Pennsylvania shares a border with Ohio, West Virginia, and I forgot what I said, and Maryland, but again, not Kentucky. Alright, now what about Maryland? Maryland shared a border only with Pennsylvania and West Virginia. So there's Pennsylvania, and here's West Virginia, but not Kentucky. So looking at it this way, there's West Virginia and Pennsylvania, but not Kentucky. Alright, finally, let's go ahead and look at West Virginia. West Virginia shares a border with all of the states except for Indiana. Okay, so there's Indiana that it doesn't share a border with, right, but it will share a border with Kentucky. So all of the states, obviously this except for itself. Alright, and again, West Virginia shares a border with all of the states except for Indiana. So it does share a border with Kentucky. So this is the matrix that we're supposed to call matrix K. Okay, and we should put brackets on it because it's a matrix. Alright, there's matrix K. Now let me remind you what the elements of this matrix mean so that you can begin to answer number 3. Now, this original matrix K, these elements represent the number of ways you can get from one state to another crossing one border. Okay? So I can get from Indiana to Ohio crossing one border in one way. There's one border between Indiana and Ohio. Now, if I were to take this matrix and say cube it, okay, we need to know what those elements would represent. If I cube this matrix, alright, it's still showing the number of ways you can get from one state to another. Just the cubing of it tells you how many borders you're crossing. Alright, so this is going to be the number of borders crossed. Okay, so if I cubed this matrix, the each element would become would represent the number of ways you can get from one state to another crossing 3 borders. I'm going to go ahead and type this matrix into the calculator. I'm not going to show every step here. I'll show a few. We'll go over to the edit menu. Alright, I think I'll put this into matrix C. Alright, so I'm going to go down to matrix C. I'll use matrix D. Alright, this is a 6 by 6 matrix, so 6 by 6. and I'll just start typing these in. Alright, so it's 0, 1, 0. 0, 0, 1. Okay, so I'll just do that over and over again until I have the whole matrix typed in. Alright, now I've typed this whole matrix in. So I'm going to quit out of here by hitting second mode. And I want to do this matrix to the third power. So I will go back to the matrix area. I'm just going to type the number 4 because that's matrix D. And that just prints matrix D on my screen. I'll use caret 3. We'll do it to the third power. Okay, so I have this matrix. I'm just going to cut and paste this onto the worksheet. Okay, so this matrix would be this is k to the third power. Now, I guess I should put the letters down the side. So each one of these elements represents the number of ways I can get from one state to another, crossing 3 borders because we cubed it. So for example, let's look at Indiana and Maryland. This 2 represents the fact that there are 2 ways I can get from Indiana to Maryland crossing 3 borders. Okay, alright, this cubed represents the number of borders I'm going to cross. So let me show you the 2 ways I could get from Indiana to Maryland crossing 3 borders. Okay, so if I start off in Indiana, I could go from Indiana to Ohio, that's 1 border, to Pennsylvania, that's another border, then to Maryland. So that's 1, 2, 3 borders. So that's one of the ways I can get from Indiana to Maryland crossing 3 borders. Let's see. Here's another way. I could start in Indiana and go to Kentucky. That's 1 border. West Virginia. That's 2 borders. And then to Maryland. That's 3 borders. Okay, so these are the 2 ways I can get from Indiana to Maryland crossing 3 borders. So anyway, in general, to answer the question, each one of these elements represents the number of ways I can get from one state to another crossing 3 borders. Obviously, if this was a 4, it would be the number of ways I can get from state to state crossing 4 borders, and so on. Okay, so that would be the answer to number 3. Alright, let's move on. Okay, I am supposed to write a system of equations representing the problem below, and then solve a matrix equation to solve the system. So let's see what we have. The tickets for your school's play are $3 for students and $5 for non-students. Okay, on opening night, 937 tickets were sold. This much money was collected. How many tickets were sold to students and how many to non-students? So we have students and non-students. Okay, so we'll let S represent the number of student tickets, and we'll let N represent the number of non-student tickets. Alright, if that's the case, then let's see, they say on opening night there were 937 tickets sold. So that gives me one little equation, the quantity equation, that S plus N should equal 937. Okay, we have some student tickets, some non-student tickets, but there's a total of 937, so they better add up to 937. But then after that, it's all about the money. Okay, show me the money. Okay, so what we have is $3, $5, and $3,943. Dollars, dollars, dollars. So when you build this equation, those things should match. So it's $3 for every student ticket plus $5 per non-student ticket. That should all add up to a total of $3,943. Okay, but this is the money equation, so you should make sure that it's money, money, money. Alright, I can't tell you how many kids will go 3s plus 5n equals 937. Well, that doesn't match. That's money and money equals tickets? No. Tickets plus tickets equals tickets. Money plus money equals money. Okay, so this is the system of equations that we need to solve. But we're supposed to do it using matrices, so we can turn this into a matrix equation by going, okay, 1, right, this is 1s and 1n, so it's 1, 1, and then 3 and 5. Okay, that is our coefficient matrix. Okay, and then next comes our variable matrix, which is S and N. Okay, in order matters. And that should equal the constant matrix. Okay, nice big numbers, 937 and 3,943. Alright, that is our constant matrix. Okay, it's important that you label these. Alright, the part that I'm about to show in red is mandatory. You must do what I'm about to do. Alright, you go ahead and label this matrix A, this matrix X, and this is matrix B. You must label that. You must write down the following two matrix equations. Alright, showing the process. Okay, so what we have here is A times X equals B, right? A times X equals B. Alright, but our theory tells us, okay, that X will then equal A inverse times B. Again, everything I just wrote here in red is not optional. When I grade your paper, I'm going to be looking for not only the blue, but also the red. If the red's missing, like -6 or whatever. Okay? So, we're trying to find X, so we're trying to find A inverse times B. So, if I want to do A inverse times B, obviously I need A inverse. So, off to the side, I'm going to calculate A inverse. Okay, so I'm just going to draw a line for a minute. So off to the side over here, I'm going to find A inverse. Now, to find the inverse, first you need the determinant. Okay, so first I'll have to find the determinant of A, which is down diagonal minus up diagonal. So that's going to be 5 minus 3. Okay, so the determinant of A is 2. Okay, now I'm in a position to find the inverse of matrix A. Alright, so the inverse, first thing I do is I take that determinant and I do the reciprocal. So I'll have that 1/2. Okay, then I can do my reverse negate in here. Reverse negate! So this 1 and 5 is going to become 5 and 1. There I reverse the down diagonal. Now I negate the up diagonal. So this is going to be -3 and -1. So this green is the inverse. Alright, if all I was asking for was the inverse, I would go ahead and divide all these by 2. But I suggest not doing that right now because of everything else we have to do. Okay, so let's get on with the mission. So we're supposed to be finding the fact that x equals A inverse times B. Okay, that's what we're doing right now. Okay, now A inverse is right here, including the 1/2. So A inverse is this 1/2, 5, -1, -3, 1. That's A inverse. Now, okay, according to our theory, x equals A inverse times B. So here's our A inverse. Now we're going to do times B. Okay, B is this big guy. All right, 937, 3943. Okay, so x should equal all of this. So all I have to do is evaluate this. Now I recommend, again, I didn't multiply by the 1/2 yet. I would multiply matrix times matrix and then divide everything by 2. It's just makes the calculation easier. Now a 2 by 2 matrix times a 2 by 2 matrix, a 2 by 2 matrix times a 2 by 1 matrix is going to be a 2 by 1 matrix. So your answer is going to be in the form of a 2 by 1 matrix like this. Alright, so the answer is going to be in the form element 1, 1, element 2, 1. So all I need to do is find those elements, and let's not forget, okay, let me move this over just a bit. Do not forget the 1/2, which is still waiting for us. Whoa, didn't mean to do that. Okay, so I'll multiply these matrices, but then I must not forget to divide everything by 2. Alright, is this always going to be 1/2? No. When I see this 1/2, I'm afraid you're going to just go, oh, so I always do 1/2, right? No, it was 1/2 because the determinant was 2. If this had been a 10, then this would be 1/10. Alright, the thing that's always 1/2 is when we're finding the area of a triangle. That's just a coincidence that this is 1/2 right now. Anyway, let's find these two elements. So, element 1, 1. Okay, so element 1, 1, that's row 1 times column 1. So row 1 is 5 and -1. Okay, column 1 is 937, 3943. So I'm doing row 1 times column 1. Okay, these are going to be big numbers, but we're going to suck it up. Alright, so 5 times 937, alright, is 4,685. -1 times this, obviously, is just going to be -3,943. Okay, so I will put these together. Alright, I get 742. So that's element 1, 1. So I can go ahead and erase that and put 742. Okay, now let's find the element 2, 1. Okay, element 2, 1, that's the second row, first column. So the second row is -3, 1. So there's my -3, 1. And of course the first column is still 937. Whoa. I say 937 and 3943. Okay. Alright, -3 times 937 is negative 2,811. And of course, 1 times this is 3,943. We'll go ahead and put those together. I get 1,132. So that is element 2-1. Okay, 1,132. Now for the final answer, I will now finally do the 1/2 that I've been saving all this time. Okay, so I will just divide each of these by 2, and that should be the final answer. So we get 371 and 566. Okay, so this is matrix X that we just found, all right, because X equals all this. So this is matrix X, and of course you recall that in matrix X the first element is the number of student tickets, and the second element is the number of non-student tickets. So we can write off our final answer in words, okay, based on the fact that we now know that, let's see, where can I write it? Basically, we know that this is S and this is N. Okay, so I'm going to put the final answer in words down here. So there you go. They sold 371 student tickets and 566 non-student tickets. That's the final answer. Anytime you're doing a word problem, make sure you record your final answer in words. Okay. Let's do the last problem. What happened to the number? Okay, so we're supposed to solve this matrix equation. Well, we're supposed to write a matrix equation and then solve it. Now, watch every step that I show, because you have to show it exactly the way I am. First, we're going to make the matrix equation like this, with your 2, -4, 2, 2, 1, -1, -4, -1, 2. All right, this is your coefficient matrix, since it's made up of all of these coefficients. All right, double checking. Good to double check. All right, there's your coefficient matrix. Then we need our variable matrix, which in this case are 3 variables in order: X, Y, and Z. Okay, and then you need equals the constant matrix, which in this case is -1, -2, and 5. Okay, so there is your matrix equation. You must write that down. Okay, when I grade your test, I'm going to be giving so many points for the setup, so many points for the answer, and so many points for the theory. Okay, what I'm about to write in red, this is the theory, and you must include it. First of all, you must label these matrices. This is matrix A, this is matrix X, and this is matrix B. All right, the theory is if we have matrix A times matrix X equals matrix B, which we do. A times X equals B. That's what we have. Then X will equal A inverse times B. Okay? Everything I just wrote in red, you must have on your paper. Do not leave this out. The labeling and these equations showing what we're doing. All right? This is the shortest way possible, but this is part of showing your work. Without it, If you just skip straight to like the scratch work, even if you come up with the right answer, you're going to lose half your points. So do not do that. This is the theory. So with this in mind, of course, we're going to be doing A inverse times B in order to find x, which is all the variables. So now we can go ahead and do A inverse times B. Now, I am giving you the inverse. See, it says right here, inverse coefficient matrix. I'm giving it to you because you don't know how to find the inverse of a 3 by 3 matrix. All right, 2 by 2, you know how to do it. So I just gave it to you. So this is A inverse. Go ahead and label that. Again, this is mandatory. This is A inverse. So we're supposed to be doing A inverse times B. So we'll be doing A inverse times B. So you can go ahead and write B next to this. All right, save yourself a little time. So -1, -2, and 5. Okay, you should label that 2. Okay, because this is A inverse times B. All right, and this should equal x. So that's why. All right, so this should equal x. And let's go ahead and set that up. All right, this is a 3 by 3 matrix. And this is a 3 by 1 matrix. So the result should be a 3 by 1 matrix. Of course, it's those outer dimensions that tell you the shape of your answer. So we're setting up a 3 by 1, so that's why we know this will be like element 1, 1, element 2, 1, and element 3, 1. So all we have to do is find these 3 elements, and we're done. Okay, because that'll be our x, y, and z. So down here underneath, we'll find all those elements. Okay, so here we go. All right, let's go ahead and find element 1, 1. Element 1, 1, that means row 1 times column 1. All right, so we're doing A inverse times B. So row 1, column 1. Please understand that this is row 1 up here. Okay, and of course this will be column 1 every time. So row 1 times column 1. So row 1 is 1/6, 1, and 1/3. Okay, that is row 1. Column 1, of course, is -1, -2, and 5. Okay, so we multiply this stuff together. So this will be -1/6, -2, and 5/3. All right, you really just are multiplying by the numerator. Okay, so we have this. And then we're supposed to add all this up and get the result. So we have to add these 3 things up. All right, we can just use our TI-30. Okay, so that's going to be -1/6. Okay, plus -2 plus 5/3. Okay, that gives me -1/2. Okay, so the first element is -1/2. Okay, so we can erase this and put -1/2 in its place. All right, now let's go ahead and do element 2, 1. All right, that's the second row, first column. So now we're doing the second row times our only column. So the second row is 0, 2, and 1. And the column, once again, is -1, -2, and 5. All right, so we're doing the second row times the first column. 0 times anything is 0, and then that's -4, and then that's 5. So you can do this in your head and see that that is 1. Okay, so element 2, 1 is 1. All right, that leaves element 3, 1. Let's do that now. Element 3, 1. So that's the third row, first column. So let's move on to our third row. All right, and same column. So the third row is 1/3, 3, and 5/3. Okay, that's third row. And once again, our only column is -1, -2, and 5. So we are multiplying these together. Okay, so that's going to give me -1/3, -6, and 25 thirds. All right, again, this is really like 5 over 1. So we're doing 5 times 5, and 1 times 3, so 25 over 3. Okay, and then again we need to add these up and find the result to the calculator. Okay, so that is going to be -1/3, so -1 over 3, plus -6, plus 25 over 3. Okay, and we get 2. Okay, so that is the third and final value. Let's go ahead and put it in there. So that's 2. All right, so because the way we set it up, we know that matrix X is X, Y, and Z in that order. So that means that's X, this is Y, and this is Z. Okay? So in other words, we know that X equals -1/2, and Y equals 1, and Z equals 2. And if we really wanted to, we could write that as an ordered triple by doing -1/2, comma 1, comma 2. We could write it that way. Alright, and that was the last problem on this little video, okay, on the warm-up worksheet here. So let's wrap up this video, and I will catch you on the next video. Okay, if all goes well, there should be 3 videos, alright, because it'll be part 1B, part 2B, and part 3B. Alright, this is the warm-up video. I'm going to try to make a video in class for the classwork, and then of course I'll make the usual homework video. So you should have a complete set if all goes according to plan.